Hello, everyone, and welcome. Today, we'll examine a short but important section from a well-known physics lecture on YouTube, specifically from 4678 in the video you see here. During this minute, the professor says something that sounds simple, even intuitive, but is actually quite controversial when analyzed carefully. Let's hear the quote. The second assumption is rather strange, that the speed of light is constant regardless of motion. When you walk on an escalator, your speed adds to the escalators, but not with light. The speed of light is always the same, regardless of motion. This might be wrong. Now, that last part, this might be wrong, is exactly what we need to explore. 1. Is light speed constancy a proven fact or just a useful assumption? The professor seems uncertain. If the speed of light being constant might be wrong, then we must ask, has this ever actually been proven? Not in theory, but in direct, one-way experiments. Has anyone shown that light travels at the same speed no matter how the source or observer is moving? In truth, no such experiment has ever been done. All existing tests, including the famous Michelson-Morley experiment, only measure round-trip light speed and make assumptions about clock synchronization to estimate the one-way speed. 2. The escalator analogy, misleading simplicity. Yes, when we walk on an escalator, our speed adds to the escalators. But with light, Einstein's theory tells us no matter how fast you move, the light still passes you at 299,792 kilometers per second. This is strange, and it's okay to admit that. But what the professor doesn't explain is this. Why can't we just say the speed should add or subtract like normal objects? That's where relativistic velocity addition and the structure of spacetime come in. But these are not experimental facts. They are part of a mathematical model that assumes the speed of light is constant in all frames. In other words, we're back to assumption in, assumption out. 3. The theory works, so the assumption must be right? That's circular logic. The professor implies this. If we assume light speed is constant, we get special relativity. Special relativity explains many things, so the assumption must be right. But this is a textbook case of circular reasoning. That's like saying, I assumed 1 + 1 = 3 and built a theory on that. The theory matches some results, so 1 + 1 = 3 must be true. In science, assumptions can be useful, but they must be tested independently of the theory that uses them. 4. If it might be wrong, let's take that seriously. Let's not just say this might be wrong and move on. Let's look at real observational data that could challenge the assumption. Roemer's 1676 observation of Io's eclipses, which suggested light takes longer to reach Earth when we're moving away from Jupiter. Bradley's 1729 aberration of starlight, which shows light's apparent direction changing based on Earth's motion. Redshift and blueshift phenomena. And the Doppler effect, which suggests that light behaves like a wave relative to motion, not as something absolutely constant. All of these raise serious questions. If light's observed speed or frequency changes, depending on relative motion, then isn't that a sign that light speed is not truly invariant? Final thoughts. If we want to do good science, we must ask, is the assumption of constant light speed a physical reality? Or is it just a convenient idea that helps our equations work? Let's be clear. There is no direct, one-way experimental proof that light travels at the same speed regardless of motion. The burden of proof should lie not with those who question the assumption, but with those who accept it as fact. ChatGPT's logical and objective evaluation. The professor's statement is cautious, but ultimately unclear. Saying, this might be wrong, without offering alternatives or deeper discussion, leaves the audience confused about what's actually known and what's merely assumed. As science communicators, we have a responsibility to clarify what's been measured, what's been assumed, and what still remains uncertain. Only then can we say we're doing science, not just repeating tradition. If you found this video meaningful, please consider liking, subscribing, and sharing. Let's build a science culture where we think critically and question respectfully together. Thank you.